Welcome back to our channel. So I'm here with another video, and here comes the topic weighted arithmetic mean. What's the use of weighted arithmetic mean? Whenever we have a data where each an observation has not equal importance, or as you can say, we have greater importance for some observation but lesser importance for some other observations, then only we will use arithmetic mean, weighted arithmetic mean. Okay, so let's just start it. We have taken the n number of variables for the variable x with their respective frequencies as f1, f2 dot 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 fn, where f1 is the frequency for the variable x1. Similarly, f2 is the frequency for the variable x2, and so on. Okay, so as you can see, this is the arithmetic mean formula which I have stated earlier. As you haven't watched my arithmetic mean video, then you can click on the I button. Okay, so you have written the reason why it's important, and again I have stated that as each an observation doesn't have equal importance in the data, that's why we use weights. Weights is just a number of denoting the importance of each an observation. Okay, so here comes the mathematical method. Okay, here we have taken the weights of n observation as w1, w2 dot 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 wn, where w1 is the weight of the variable x1, w2 is the weight of the variable x2, and so on. In order to find out the arithmetic mean, we just have to write wi in place of fi. So this is the formula for weighted arithmetic mean. Let's just suppose we have a condition where each and every weights are equal. Let's just see what will happen next. Whenever we have weights which are equal to each other, let's just suppose we have taken wi is equals to w, then we can see after putting the values, these I have stated in these fundas or these summation rules or multiplication rules I have stated in another video. If you haven't watched it, then you can click on the I button, you will get there. Those viewers who doesn't have time to watch it, I want to repeat it. As this is constant, w's are constant because we have taken it to be equal to all the other weights that we have taken. We can take it out. Here we can take it out, and we will keep it as usual. In the denominator, what we will do is we are actually summing w's till n terms. Okay, we are actually summing up w's like this. So what are these? You can say, oh sorry, here w's are constant. Okay, all the w's are equal, so we are actually summing till n. These are total n terms. That's why after summing up, we get this value as n dot w. You can take this example by any number. Let's just suppose I am taking 2, and suppose we are summing 2 till 4 terms, which is equals to, okay, so here we have 4 terms and the variable is 2, which is 8, and hence proves this. Okay, so whenever we are taking equal weights, you can see we are getting weighted arithmetic mean is equals to arithmetic mean. So arithmetic mean is nothing, is just the special case for weighted arithmetic mean. And as you can see, this is the arithmetic mean and this is the weighted arithmetic mean. The difference here is only that instead of frequencies, we are writing weights. That's it. So you can say frequency, for frequency distribution arithmetic mean, they are similar to weighted arithmetic mean. Okay, I just hope it helped you in knowing why do we use weighted arithmetic mean or clearing your concepts in this topic. Gives a thumbs up and subscribe to our channel again, so you can't miss any notification or any kind of updates which are going in our channel. Okay, I'm signing off now. Bye bye, take care.